Okay, so the directions here say solve by completing the square. So we have a quadratic, and we don't really want to use graphing for these, and we don't want to use factoring. We would want to use completing the square. So step 1 is to get C over to the other side. You add 40 to both sides, and I tell you to leave a space. And when we have C over to the other side, 2, divide every term by the A coefficient. You cannot have an A coefficient in completing the square, so we divide every term by 3. In this problem, this actually works out nicely because we can divide every term by 3, and they all divide evenly. At this point, we do completing the square. We do completing the square by doing B over 2 squared, and that's the value that I added here and added here. B is -2 divided by 2 is -1 squared, which is 1. So we add 1 to both sides of the equation. Here we factor, and here we simplify. These steps are always the same. The math, obviously, the factoring, the simplifying, whether it has fractions, but the steps are always the same. Whatever problem you're working on right now, you can use these same. We want to know what multiplies 1, but adds to -2, which is -1 is -1, 1 and -1. So -1 is negative. So I get parentheses of x minus 1 times x minus 1 equals 16. And we want to write this as x minus 1 squared equals 16 because in completing the square, we end up taking the square root of both sides. So we get x plus 1 equals, and whenever you put a radical in a problem, you get plus or minus, and the square root is 4. To get x by itself, we're going to add 1, and you get x equals, you put squigglies, and we do the minus as the lower number and the plus is the bigger number. So -4 plus 1 is -3, and 4 plus 1 is 5. And those are your solutions. Always put in squigglies. Now, another way that we use completing the square is to convert from standard form to vertex form. So that this is a little bit more difficult using the same stuff. Still, we always add b to the side, or move c to the other side. So we have f of x2 equals 2x squared minus 4x. And the ones we did in class may have had a y. These have f of x, which is no different. Now, we always take out not necessarily the greatest common factor, but a common factor, which is a. You always factor out a, whatever a is. And here a is negative. So take out -2, x squared plus 2x, because you're technically dividing everything by -2. All right, and then again, leave your space. And what goes in that space is b over 2 squared. B is 2 over 2 squared, which is 1 squared, which is 1. And what we discussed in class, what makes these more difficult is that you're not technically adding a 1 to the right side of the equation. You're adding a -2 because you're adding a 1 that in the end is actually getting multiplied by -2. So I'm not adding a 1 to the right side. I'm adding a 1 times -2, which is -2. So what we have to end up doing is adding a -2 to this side as well. And we get plain old f of x equals -2. And then we have to factor what multiplies to 1 and adds to 2, which is 1 and 1. And you actually don't have to add or subtract anything in the end. And this tells me that my x is -1, 0, because there is nothing at the end there. And I also know that it's reflected because of the negative out front, and then it has a stretch. by a factor of 2. So it's going to be an upside down parabola. If I was to make a little sketch of this, basic, nothing fancy, would go to -1, 0, and I know that it's going to be a little bit skinnier than the average parabola, and then it's going to be down facing. So it would look approximately like that. So that's an option on graphing. If you don't like to graph in standard form, this is an option, even though most of us are pretty good at graphing in standard form.